Welcome to Basic Electricity Tech TV, where we will be taking the mystery out of basic electricity. Hello and welcome. Welcome to another episode of Basic Electricity Tech TV. In this episode, we're going to examine some of the properties of parallel circuits. Stay tuned and thank you for watching. Okay, this is a demonstration of our parallel circuit projects. I've used light bulbs to simulate the resistors in our circuit. I've got power coming in on this rail, coming across on our 2-branch wires, across each the resistors, and back out to ground. And on this side I've got power coming in on the outer rail, up to our 2-branch wires, up to our 2 resistors, down on our outer rail, and back out to ground. So let's see how it looks. We've moved down to the second position. We've got 1, 2 resistors, and a 3rd resistor. And we've got 1, 2 light bulbs, and 1 3rd light bulb. Once more, we've got 2 resistors, and 2 more resistors down here. We got 1, 2 light bulbs, and 1, 2 light bulbs. Move down to the 4th position. We've got 1 resistor, and 1, 2 light bulb, resistors, and 1, 2 light bulbs, and 1 light bulb up here. And that simulates our circuit, our parallel circuit. Okay, for the resistance in a parallel circuit assignment, what I expected you to do was read through the instructions. Review the assignment wiring diagram 240005, sheets 1 through 4. Review the equipment list. Determine which resistors to use. Calculate the total resistance for each one of the diagrams. That's for 4 different diagrams. Mount the resistors on the breadboard as per the wiring diagram. Connect your meter to read resistance. And in the submissions box, click on the 3 dots in the upper right hand corner, create a spreadsheet, calculate the total resistance for each wiring diagram, use your multimeter to measure the resistance, and enter your findings in the table. Compare your calculated and your measured values, and then upload the spreadsheet and upload pictures. So let's go ahead and do that. Now, in the picture, I have used light bulbs instead of resistors, and I have my meter connected to this rail down to this point and this point through my little jumper. So I'm actually connected across this light bulb and this light bulb. I'm actually reading the resistance of 2 light bulbs in parallel. I'm set on a 200 ohm range, and I'm reading 49.3 ohms for 2 light bulbs. Now you were supposed to use carbon resistors, so the concept is the same. I'm just showing you how I did it here. As far as the calculated value, it would be whatever you calculated using that inverse formula. Let's go ahead and enter my values here. 49.3 ohms. And let's go ahead and get rid of that one. This is the next one. Moved my wires down to the 2nd position. This will be the 2nd wiring diagram. I am now connected across 1, 2, 3 light bulbs. My total resistance is indicated as 32.7 ohms, so I can go ahead and put that in there. 32.7 ohms. And we can get rid of that. We don't need that right now. Let's go ahead and look at the next one. I am down here at the 3rd position. I'm reading across 1, 2, 3, and 4 resistors, or light bulbs. My resistance went down to 24.7. 24.7 ohms. And lastly, let me get rid of this one. And of course, my last position here, I am down here to read 1 light bulb, and 2 and 3 light bulbs. and I'm back up to 32.8 ohms. 32.8 ohms. Now, light bulbs being what they are, I don't know the exact resistance for them, so I don't have a calculated value. But when you look at your carbon resistors, you will have color codes that will tell you what the calculated value is. And you can compare the calculated value from the color codes to your measured value and determine whether it's within limits. And what I want you to do is recognize when these two numbers are very far apart, something went wrong somewhere. Be able to recognize when there's a problem. Okay, hope that helps you. The first assignment was simply reading resistance. Have a good day.